So moving right on along into one-step equations. We are now going to be moving into equations. So real quickly, let's go back over the differences between an equation and an expression. So remember, with an expression, we would see answers like hello. Why is it doing that? Our answers would look like 2x plus 3 versus in an equation, we now see an equal sign. When we do see an equal sign, our answers will be single digit numbers. Okay. And before I forget, this will be page 12 in your notebook. Okay. So solving an equation allows us to find a missing value or variable. The letter called the variable must be alone or isolated on one side of the equation. You isolate that variable by using inverse operations. Another word for inverse is opposite. Opposite operations. Okay, remember we have four main operations: add, subtract, multiply, divide. And those operations, if you look at your calculator, you can always find them here on the right side. Add, subtract, multiply, divide. Okay. So when we think about it, the opposite of adding is to subtract. The opposite of multiplying is to divide. Now, the only reason I didn't go ahead and write the symbols for multiplication and division, man, my writing's ugly, is because we have special ways to represent multiplication and division. So for multiplication, don't forget, we either use a dot or parentheses. For division, we no longer use the symbol that you see here on the calculator, the line with the two dots. We have to represent division in the form of fractions, okay? Very, very important that you keep your equation balanced. Now, when we talk about your equation being balanced, remember we're going to start moving things, numbers, variables across the equal sign. So just because it moves across the equal sign doesn't mean it disappears. It still has to go somewhere. So we go from the left to the right or the right to the left, depending on certain things, okay? You can always check your answers by substituting your answer back into the equation, plugging it back into the original equation. Okay. Now, fraction is one thing that I see we don't get enough practice of, but to eliminate any fraction, we multiply by what we call the reciprocal. Now, you should have been exposed to this term, this vocabulary word, reciprocal, but just in case you haven't, let's say, for example, I have the fraction 2/3. The reciprocal of 2/3 would be to take that fraction and flip it upside down, 3/2. And it's not keep, flip, change, okay? You're not changing the sign of the fraction or anything like that. You're just flipping the numbers. So, for example, if you have -4/5 and you flip those numbers, it'd still be 5/-4, okay? Literally, all you do is flip it, okay? So, for number one, it says write and solve the equation represented below. Now, on the STAR test, you will not see algebra tiles, okay? Won't see algebra tiles, but for purposes, just because you guys are so used to seeing the algebra tiles last year, we're going to go ahead and start with that, okay? First, let's write the equation. We have 1x plus 1, so x plus 1 is equal to 8. Okay, now the whole point of isolating the x, or the whole point of solving an equation, is to get the x by itself. And we know that the x is on the left side of the equation, right? So that means, and anytime we're solving an equation, I like to split up my left and my right sides, okay? So if my variable is on the left side of the equation, I need to be moving my numbers to the right. Now notice 8 is already on the right side of the equation, so I need to move the 1. The 1 is connected to the x with a plus sign. The opposite of plus is minus, but just because I subtract the 1 doesn't mean it disappears. It goes to the other side of the equal sign. Okay, and we're left with just x. 8 minus 1 is the actual math that you would end up doing, which would be 7. And that is your solution. Now you can double check yourself. Let's write this down though. X is the equation, the solution is x is equal to 7. You can check your answer by taking that 7, plugging it back into the original equation. The original equation that we had written was x plus 1 equals 8. So if I take the 7, plug it back in, when we substitute, think about right now. You guys are working with a substitute that's in my place, right? That means I am being replaced. I am not physically there. My substitute is there. So we're going to replace the x with the 7. Now, when I work this side out mathematically, 7 plus 1 is 8. 80 equals 8 is a true statement, meaning that we did find the correct answer. And we're not going to do this with every equation. This is just one way to show you how to check your answers. Okay. Let's try the next one. This one's kind of written backwards. So let me see. 1, 2, 4, 6, 8, 10, 12. And this is 3 x's. All right. This is where a lot of students are going to get confused, mixed up. They're going to add, subtract, whatever, right? A lot of students fail to understand that just because, well, when we're solving equations, we're trying to isolate. Let's start there. When we're solving equations, we're trying to isolate the variable, correct? So I'm going to split up my sides into left and right. This time I notice that my x is on the right side, so my numbers have to be moved to the left side of the equation. 12 is already on the left side of the equation, so it means that I need to move the 3 from the right side to the left side, okay? The only way to move this 3 is to use inverse operations, is to do the opposite, right? Now, with that 3x, this is where we get confused. If it were plus, you would be able to physically see a plus sign between them, and you would see it as 3 plus x. So you change the plus to a minus. If it were minus, you would physically see with your eyes a minus sign in between them, and your minus would change to a plus. If it were division, division is easy because you see it in the form of a fraction. Notice this right here doesn't look like any of these here that we just wrote on the side, correct? That is because it is multiplication. It is understood to be multiplied, okay? The thing that is connecting them invisibly is a dot, okay? Anytime you have a coefficient, that means multiplication, 3 times x. So the opposite of multiplying that 3 is going to be to divide. Now, I do not want to see you guys writing division this way. You turn it into a fraction. How do you turn anything into a fraction? You turn it into a fraction by drawing the division sign, the bar. okay? And you divide it by 3. You do the same, whatever you do to the right, you do to the left side. When you have the same number, those are the ones that are going to zero out. They're going to, what I typically say, cancel out. And you're left with X by itself. Now, you can type this if you forget that that represents division. You can type it as a fraction in the calculator. It'll give you 4. Or you remember that it is division. 12 divided by 3 is 4. Okay. So our equation was 12 is equal to 3x. Our solution is x is equal to 4. You can write it either way. Okay. But just remember, where you see the same number, those are the ones that zero out, that cancel out. Like over here in this example, the number that zeroed out or canceled out was the number 1. 1 minus 1 is 0. This is what you put into the calculator. Okay. Number 3, without algebra tiles. Let's do it without the training wheels. We don't need them anyway. Here we go. First thing you want to do, draw the line. Label your left and your right side. Find your variable. Our variable is x. X is on the left side, so our numbers must move to the right side. 8 is already on the right side, so I must move the 1 over to the right. X and 1 is connected to the x with a plus sign, so we change it to a minus sign. Just because we get rid of it doesn't mean it disappears. So you get x equals 7. And that ended up being the same exact equation as the one above, but it's okay. Helps to practice. Might not need a calculator for this lesson. Next one. First thing you want to do, split up your left and your right side. Okay. Find your variable. What is my variable? My variable is f. F is on the left side, so I need to move my numbers to the right. 11 is already on the right side, so I need to move the 2. How is 2 connected to f? With the minus sign, so the opposite of minus will be plus. Where I see the 2 2's, that cancels out, it zeroes out. This is the math that I have to do. 11 plus 2 is 13. Okay, now when I get back and we continue to solve equations, because this is something that we're going to be doing the whole year, I will expect you to tell me what step to take and why you are taking that step. So make sure you know all of these things. I don't do, we're going to color this green, we're going to color this red, whatever. No, in algebra, you need to know what step you're taking and why you're taking that step. I am adding the 2. Why am I adding the 2? Because it's a minus, and the opposite of a minus is a plus. And we're moving the 2, not the 11, because 11 is already on the opposite side of the variable. Okay? Things like that. Number 5. 5 is one a lot of students are going to mess up, especially those of you that like to rush through things. So first thing we want to do, draw our line, hopefully a straight line. Label our left and our right side. Our variables on the left, so we move our numbers to the right. About 5 out of 10 students are going to see this minus sign right here, and they're going to say, okay, plus 4. Wrong. You need to see what is connecting the 4 to the P. When we talk about connecting the number and the letter, once again, it's connected through the middle. Okay? So let's talk about it. Do you see a plus sign in between? No. Do you see a minus sign in between? Very specific, in between. No, you do not. Is it in the form of a fraction? No, it is not. That means that there is an invisible dot there, okay, that represents multiplication. And the opposite of multiplying that 4 is going to be to divide it, okay? Here's another thing that students get confused with. Just because we went from plus to minus here, or minus to plus, doesn't mean we go from minus to plus here. This is going from from multiplication to division. Totally different thing. Whenever you're multiplying and dividing, you do not change the sign. You don't go from minus to plus. The only reason we're going from minus to plus here is because we're going from addition to subtraction, okay? I really, really hate whenever they teach you positive changes to negative. No, plus changes to minus. Plus changes to minus, okay? Um, anyway, times -4 changes to divide -4. Do not change that to a positive, okay? Anyway, these are the ones that cancel out. This is what you put into your calculator. 48 divided by -4, and you get -12. Moving on. Number 6. Draw your line, label your sides. My variable is on the left, so my numbers must move to the right. 9 is already on the right side, so that means I need to move this 3. What do you notice about this? It is in the form of a what? Fraction. And what do fractions represent? Division. Notice it's the same thing, except you have number and letter replacing those dots. It's division. Now the opposite of dividing the -3 is going to be to multiply the -3. Once again, just like with division, you do not change negative and positive. You only do that when we're adding and subtracting. We're not adding and subtracting here. 9 times -3, -27. Okay. The one-step equation, you should have been working on one-step equations in 6th grade, but you might be hearing it a little differently for the first time. I'm trying to see if it's not letting me move. There we go. This is a different type of fraction, okay? With this one over here, we know, not that one, sorry. With this one, we had the letter above the number. What's different about this one is we actually have a full fraction. We have a numerator and we have a denominator, okay? So we have to think about it. What do fractions represent? Fractions represent division. Let me erase that. Don't write that down. Come on. Fractions represent division, okay? So how do you get rid of a fraction? Go back to your notes. To eliminate a fraction, what are you going to do? Multiply by the reciprocal. Multiply by the reciprocal. If fractions already represent division, the opposite of dividing is to multiply. And we multiply by the reciprocal. What is the reciprocal of 5/6? 6/5. Okay. Now let's look at this. Notice here, top 4 got rid of the bottom 4. Let me go over, if it lets me. Bottom 3 got rid of the top 3. Let me go backwards. Top 2 got rid of the bottom 2. Let me go over. Top 1 got rid of the bottom 1, right? So when we create that reciprocal, top 6 gets rid of the bottom 6, top 5 gets rid of the bottom 5. So these cancel out. Sorry. So we're left with just M. Okay, yes, you can work this out in your head, but to avoid mistakes, I suggest you do it in the calculator and type it in correctly. Not like me. 6/5, not 5/6, which gives us 12. Okay. Next one. Very important that you draw your line, label your sides, because what do we see now? Our letters on the right, so our number needs to move to the left. Fractions. Fractions represent division. The opposite of dividing is to multiply. But because it is a fraction, to get rid of a fraction, you multiply parentheses by the what? Reciprocal. When we create the reciprocal, you do not change negative and positive. Top 4 gets rid of the bottom 4. Top 3 gets rid of the bottom 3. You're left with just a y. So 4 over negative. Go to the side before you close your parentheses. 4 over negative 3 times 9. Notice I typed it in the calculator exactly the way it's written here. And we get negative 12. I think 12 is a very popular answer with this set of notes. Just FYI. Okay. Next, number 9. Going back to the easy ones, hopefully. We'll see. Our letters on the left, so numbers need to move to the right. Okay. 7.5 is already on the right side, so we need to move the 2.5. 2.5 is connected to x with a plus. Plus changes to minus. Please do not say positive changes to negative. Plus sign changes to minus sign. Okay, 7.5 minus 2.5 equals positive 5. Okay. Here we go again. Letters on the left, move the numbers to the right. The number I need to move is the minus 1/10. Minus changes to plus. Minus changes to plus. So 1/2 plus 1/10. Let's type it in. Just because we don't want to have to go through common denominator, all that good stuff. Gives us 3/5. Next, draw your line, split your sides. Letters on the right side, so numbers move to the left. What is connecting 9 and H? Remember, always look between. Since I don't see anything in between, that automatically means it's multiplied. The opposite of multiplying a 9, divide the 9. Okay. Divide the 9. Type that in. You get negative 12. Type it in as a fraction. Type it in exactly the way you wrote it down. Don't make it harder than it is. Number 12. Letters on the right side. So you move the number to the left. Number that needs to move is 7. How are they connected? With that little bar. What kind of bar is that? Division. K divided by 7. So the opposite of dividing 7 is to multiply 7. Top 7 gets rid of bottom 7. 7 times negative 9. Negative 63. Last example. Remember, equations is all about keeping balance. Just because you move something across the equal sign doesn't mean it disappears. So first, let's write our equation. These two weights are what? Equal. Okay, so what do we write on this side? X, there's 5 negative boxes, so negative minus 5. That's ugly. Okay. We have 9 boxes with a positive 1, so it equals 9. Okay. X minus 5 equals 9. What is our solution? What is our answer? Let's find out. Split your sides. Letter is on the left side, so you move the numbers to the right side. What number do you move to the right? The minus 5. A minus sign changes to a plus sign. Okay, these are the same number, so those are the ones that zero out. 9 plus 5 is 14. Okay, now it's your turn to practice.